Hello and the warmest of welcomes to each and every one of you tuning in today. It is an absolute pleasure to have you here. Before we embark on this truly mind-bending journey into a hidden aspect of our own existence, I want to take a moment to genuinely thank you for your time and to wish you and your loved ones the very best of health, happiness, and peace. In this big, wide world, your presence here means a lot, and I sincerely hope you're feeling fantastic today. Let's explore something incredible together. Have you ever walked into a completely dark room, waited for your eyes to adjust, and marveled at the profound blackness, believing you were utterly invisible? It's a universal human experience. What if I told you that in that very moment of perfect darkness, you are not dark at all? In fact, you are glowing. You are emitting your own personal, very faint light. This isn't a metaphor or a spiritual concept, it's hard, biological fact. Every single one of us, right now, is shining with a tiny amount of visible light. This light is far too weak for our eyes to see, but it is real, it is measurable, and it is a direct window into the furious, energetic dance of life happening within every cell of your body. This phenomenon is known as biophoton emission or ultraweak photon emission, and it is one of the most fascinating secrets our bodies keep. To understand how we can possibly produce light, we need to take a deep dive into the very engine of life, the cell. Think of every single cell in your body as a bustling, microscopic city. This city needs power to run. That power comes from tiny structures within the cell called mitochondria, often called the powerhouses of the cell. Their job is to take the molecules from the food we eat and combine them with the oxygen we breathe in a controlled, step-by-step process to create a special energy currency molecule called adenosine triphosphate, or ATP. This process is called cellular respiration, and it's how virtually all complex life on Earth powers itself. Now, this process is incredibly efficient, but it's not perfect. Just like in any highly complex factory, there are byproducts and occasional sparks. The primary sparks in this cellular factory are highly reactive, unstable molecules called free radicals. The most common free radicals involve oxygen, like the superoxide anion. These molecules are unstable because they have an unpaired electron in their outer shell, and electrons desperately want to be in pairs. So, these free radicals zip around the cellular city, trying to steal an electron from any other molecule they bump into, from proteins, from fats, even from DNA. This electron theft is a process called oxidation, and it can cause significant damage to the delicate machinery of the cell, a concept known as oxidative stress, which is linked to aging and many diseases. This is where our body's incredible security team comes in, antioxidants. These are molecules that generously donate an electron to a free radical, neutralizing it and stopping its rampage. But here's where the magic happens, quite literally. When a free radical is neutralized by an antioxidant, or when two free radicals interact with each other, the energy from that electron transfer can sometimes be released not as heat or sound, but as a tiny packet of light, a photon. It's a bit like a microscopic electrical spark. This is the fundamental source of the light your body emits. It is a byproduct of the essential metabolic processes that keep you alive from one second to the next. The light is a signature of the constant biochemical reactions, the endless cycle of oxidation and antioxidation, that defines a living organism. You are, in a very real sense, illuminated by the fire of your own metabolism. Now, you might be thinking, if I'm glowing, why can't I see it? Why can't I see other people glowing? The answer is simple: the light is incredibly faint, or ultra-weak, as scientists call it. We are talking about emitting just a handful of photons per second per square centimeter of skin. To put that into perspective, the light from a typical candle is literally billions of times brighter than the light coming from your body. Our eyes are remarkable organs, but they have their limits. They are simply not sensitive enough to detect such an incredibly dim signal, especially when they are constantly bombarded by vastly brighter light from other sources, like the sun, light bulbs, or even starlight. It would be like trying to hear a single person whispering in a quiet library versus trying to hear that same whisper in the middle of a roaring heavy metal concert. The signal is drowned out by the noise. So, while the light is technically visible light, falling within the same spectrum we see every day, its intensity is far below our visual threshold. How, then, do we know it's there? We know because of incredible technology that acts as a superpower for our senses. Scientists use incredibly sensitive instruments called photomultiplier tubes or single-photon counting cameras that are kept in perfect, deep-freeze darkness at temperatures hundreds of degrees below zero. Why the cold? Because cooling these devices to such extreme temperatures drastically reduces their own internal noise, allowing them to detect the faintest whisper of light without interference. These devices are so sensitive they can literally detect a single photon. A person is placed in a light-tight, sealed room that is completely, utterly black, a room so dark it makes the darkest night you've ever experienced seem bright. They sit there for long periods to allow their eyes to adjust and for any residual light from their clothing or skin to fade. Then, these hypersensitive cameras are turned on, and over minutes or hours, they slowly and patiently count the individual photons of light that are emitted from the person's skin. This is how we have the beautiful, color-coded images you might have seen online, showing a human body aglow with a soft light, brighter around the head and hands. Those images are not taken with a normal camera, they are painstakingly constructed from hours of data collected one photon at a time. The patterns of this light are not random. They form a map of your body's metabolic activity and overall vitality. Studies have shown that this glow follows a circadian rhythm, it's brighter during the day and dimmer at night, mirroring your body's cycle of activity and rest. The face and neck tend to emit more light than other parts of the body, perhaps because they are more exposed to the environment and have higher metabolic activity. Furthermore, this light emission is not static. It changes with your health. When the body is under oxidative stress, when there is an imbalance between those damaging free radicals and the protective antioxidants, the light emission can actually increase. This makes sense because more free radical reactions mean more opportunities for those light-releasing interactions. Therefore, researchers are actively studying biophoton emission as a potential non-invasive diagnostic tool. By measuring the pattern and intensity of a person's light, doctors might one day be able to detect inflammation, monitor the progression of diseases like cancer or diabetes, or even assess the effectiveness of certain treatments or antioxidants, all by simply listening to the light their body is already producing. This concept of living things emitting light connects us to the wider universe in a profound way. This type of light that is produced by a chemical reaction within a living organism, is called bioluminescence. We see it in fireflies lighting up a summer night, in certain species of fungi creating eerie glows on forest floors, and in the incredible light shows put on by creatures in the deepest, darkest parts of the ocean. While the mechanism in fireflies, which involves an enzyme called luciferase acting on a molecule called luciferin, is much more efficient and brighter than our own ultra-weak glow, the basic principle is similar. Energy from a biochemical reaction is released as visible light. Your body's faint glow is your own personal, very subtle version of a firefly's flash or an anglerfish's lure. It's a reminder that we are not separate from the natural world, we are a part of it, sharing fundamental biological processes with the most exotic of creatures. So, the next time you find yourself in a quiet, dark space, know that you are not shrouded in darkness. You are a walking, talking lantern, emanating a gentle light that tells the story of the life force within you. Each tiny photon is a messenger, carrying news of the ceaseless metabolic dance between energy and matter, between damage and repair, that defines your existence. You are literally made of stardust, and you are shining, however faintly, with the light of life itself. It's a hidden, beautiful truth about who we are, a secret light show happening on our skin, waiting for technology to reveal its subtle glory. Thank you so much for joining me in exploring this incredible hidden aspect of our being.